Welcome in Dark Core. Scott Kelly is a lot of things. An American engineer, a retired astronaut, and a time traveler. Wait, what? Kelly commanded the International Space Station on several missions. On one of those trips, he spent 340 days aboard the giant floating science lab orbiting Earth. While he was up there improving the water recycling system, testing heat transfer in microgravity, and doing all the other genius-level stuff astronauts do, he was also aging. But not like you, me, or even his identical twin brother, Mark. He was actually aging slower than all of us. Okay, so both brothers are astronauts and have been to the International Space Station. But Scott spent way more time up there, about 10 times as long, actually. And here's where things get more interesting. Even though Mark was born 6 minutes before Scott, he is now 6 minutes and 5 milliseconds older. That happened because Scott aged a little more slowly while he was orbiting the Earth. And astronauts age slower because they're moving much faster than us at 17,500 miles per hour. Basically, the faster you go, the more time stretches out. So, the closer you get to traveling at the speed of light, the slower you age. From Scott Kelly's perspective, nothing felt unusual up there. Time passed like normal for him, but he actually aged less than his twin brother over the same period of Earth time. So when he returned, we can say that he had essentially leapt forward in time relative to us. So if traveling close to the speed of light lets us leap forward in time, that means astronauts have already kind of achieved time travel. Sure, it's a bit of a letdown that it doesn't happen like Back to the Future. You know, hopping into a cool futuristic car and zipping into another timeline. But this is real. At least according to some scientists. Real-time travel isn't about jumping from one moment in time to another, like going back to the age of the dinosaurs, then hitting a button to fast-forward to the year 2100. The time travel that's possible today is more about actually living into the future. It's about moving faster than 1 second per second, just like Scott Kelly did. To explain the theory behind this wild idea, we have to bring a celebrity into the conversation, Albert Einstein. Think about your childhood and your retirement. Whether it's in your past or your future, time always ticks at the same steady rate. But then along comes Einstein saying, sure, but it's not that simple. He introduced the idea that time is relative. In other words, the amount of time you experience compared to someone else depends on what you're both doing. And where exactly you are in the universe, time is not the same for everyone. Here's an example. You're sitting on a bench holding a melting ice cream cone. Meanwhile, your friend zooms past in a super fast spaceship. For you, maybe the ice cream melts in 5 minutes. But for your friend flying at a crazy speed, this same scene took less time on his watch. That's time dilation. Time actually moves slower for things that are moving faster. That's the heart of what's known as special relativity. We actually proved Einstein's theory back in the 70s. 2 scientists took super-accurate atomic clocks and flew them around the world on planes. First going east, then west. They compared those clocks to a third one that stayed on the ground. When all 3 were brought back together, they showed different times. The clock that flew east in the direction of Earth's rotation lost 59 nanoseconds and it was moving faster relative to the ground. The one that flew west against Earth's rotation was moving slower. So it gained 237 nan. Now think about those astronauts living in space moving way faster than we are. They travel at about 5 m per second, orbiting Earth roughly every 90 minutes. If you do the math, spending 1,000 days up there lets you skip about 0.027 seconds into the future. I know that doesn't sound like much, but that's because the speed of the ISS is tiny compared to the speed of light. Still, if we keep going with that idea, it pretty much makes the astronaut Oleg Konenko humanity's greatest time traveler. In 2024, he set the world record for the most time spent in space, 878 days in orbit. Okay, so we now know that Kelly and Konenko are in a way living in the future. But what about traveling backward in time? Well, I'm sorry to say traveling back to your glorious high school days is a whole lot trickier. In theory, we could, but in practice, it's pretty much impossible. Imagine space and time as this big stretchy fabric, and gravity is what bends it. Kind of like when you put a heavy bowling ball on a trampoline. In theory, If you could bend it just right, you might create a shortcut through space and time called a wormhole, a tunnel that connects two different points. Let's say the present and the past. Now, usually gravity pulls things inward. It wants to collapse tunnels, not keep them open. So, the walls of this tunnel are constantly under pressure from the universe trying to squish them shut. To stop that from happening and to keep the tunnel open long enough for something or someone to go through and get to the past, you need something that pushes outward against the collapse. And that's where negative mass comes in. Negative mass is a weird theoretical idea in physics. Unlike regular mass, which pulls things together with gravity, negative mass would actually repel things. It would push away instead of pulling in. It's like using anti-gravity to keep the tunnel from closing. It would act like braces holding the tunnel open from the inside. But here's the problem. We have never actually seen negative mass. It's just something that might exist on paper in math, but no one's ever found any in real life. Plus, there's something called the self-consistency principle. Basically, it says that time travelers can't create time paradoxes like those crazy scenarios in the butterfly effect movie. Let's say you go back in time to stop your granddad from meeting your grandmother. But here's the problem. If they never met, that means your parents were never born. And if they weren't born, well, how do you exist? That's a time paradox. Something that causes all sorts of inconsistencies in the universe, making everything a total mess. And according to the self-consistency principle, that's impossible. It just can't happen. Some specialists, though, think they have an answer to the grandfather paradox. All we need to do is think about time as an endless loop with no starting point. In a closed time-like curve, as this theory is called, the past and present blend together in an eternal time loop. There's no way out. There's no changing things. It would all look the same if played in reverse. For example, what did you do yesterday? Let's say you woke up, brushed your teeth, worked all day, had your meals, and then went to bed again. Following the closed timeline curve theory, if you could go back to yesterday, you do those exact same things in the same order no matter how hard you try to take the day off. Because in a closed time-like curve, you're attracting not just your steps, but every single second of reality itself. And that's the only way time travel could be possible. So even if we somehow manage to build a time machine, and even if we give it our best shot to change the past, nature will always find a way to prevent contradictions. In the end, everything would have to align perfectly to keep our history from becoming a mess. That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the Dark Core. Thanks for watching Dark Core.